For thousands of years, we've thought of concrete as a simple, stable material. Basically, man-made rock. But that view, well, it's obsolete. Today, concrete is a high-tech, liquid system. It's a complex chemical reaction that has to be perfectly controlled from the moment it's created to its final placement. Our ability to build the modern world literally depends on getting this control right.
So what does that really mean? It means from the second it's mixed, concrete begins a countdown to failure. The whole process is filled with risk, where one tiny mistake in timing, temperature, or its composition can compromise the integrity of an entire structure. So the challenge isn't just making concrete, it's mastering it against a ticking clock.
All right, so here's our game plan. We're gonna follow the journey of smart concrete, starting inside the precision factory. Then we'll explore the digital systems that control it, see how the material itself is evolving to heal and even absorb CO2, face that critical 90-minute delivery window, and finally, see how all this tech creates an unbreakable record of quality.
Okay, let's start where it all begins, inside the modern ready-mix concrete plant. Now, this isn't just some simple factory. Think of it more as a laboratory, and it's designed for one purpose: to take a chemical reaction that is fundamentally chaotic and force it to perform with absolute precision every single time. You see, the whole process is an exercise in control, designed to flow downwards with gravity for maximum efficiency. Raw materials are stored, then weighed down to the gram by automated systems. High-intensity mixers make sure every single particle is perfectly coated. And at every stage, sensors are monitoring key variables like temperature and its consistency or slump, validating the mix before it even thinks about leaving the plant.
This entire system, all this technology, is built around one absolutely critical variable: the water-cement ratio. You can think of it as the recipe. It's the one thing that dictates the final strength of the concrete. If you get it right, the structure is durable. If you get it wrong, the integrity is shot before the concrete even sets. So every single piece of tech in this factory is there to protect this one ratio.
And to give you an idea of how sensitive this is, a 1% change in the moisture of the sand, an amount you can't see or feel, is enough to throw off that water-cement ratio and completely ruin an entire truckload. This is the chaos the system is built to control.
So how do you solve a problem you can't even see? Well, the old way was unreliable, a worker taking a sample here and there. The new way makes the invisible visible. As sand falls into the hopper, microwave sensors scan it hundreds of times per second, detecting its exact moisture content. The system's AI then instantly adjusts the amount of water added to the mix to compensate, perfectly protecting that critical ratio.
Okay, so controlling a single variable like moisture, that's just the beginning. The next step is to orchestrate the entire system, and that's done using a digital twin, a complete virtual replica of the plant and all its logistics, designed to manage the incredible complexity of production and delivery.
And each problem has a precise technological solution with a real-world impact. So, a problem like inconsistent workability gets solved by AI and moisture probes. The result? 0 rejected loads. Bottlenecks with trucks at the plant are solved by simulating schedules in that digital twin, which leads to optimized deliveries. And a lack of accountability? Well, that's solved with blockchain, creating a permanent, unchangeable quality record for every single bat.
Now, this level of control isn't just about the production process anymore. It's being engineered right into the material itself. We are designing concrete to not only be stronger, but also to be more sustainable and even to repair itself, which addresses its long-term impact and life cycle costs.
And to really get why this matters, you have to look at the scale of the problem. The production of cement, which is the key ingredient in concrete, is responsible for about 8% of global CO2 emissions. This massive environmental footprint is what's driving the need for a whole new generation of green concrete.
One of the most powerful solutions here is carbon sequestration. And here's how it works. Captured CO2 gas is injected directly into the wet concrete mix. A chemical reaction starts, and the gas mineralizes. It turns into solid calcium carbonate, basically limestone, and it's trapped forever inside the concrete. And get this, the result is not just permanent carbon storage, it actually makes the concrete strong.
But what if concrete could fix its own failures? Well, inside some advanced mixes, dormant bacteria, Bacillus pasteuria, are added. They just lie there, sleeping inside the concrete matrix, waiting for a very specific trigger.
And here is that trigger. In traditional concrete, a crack is pretty much the beginning of the end. But in this new technology, a crack is a signal. Water seeps in and it wakes up the bacteria. They start consuming nutrients that were packed in the mix right alongside them, and they excrete limestone, sealing the crack perfectly from the inside out.
The damage itself actually initiates the repair.
All right, now we leave the controlled environment of the plant and we enter the most dangerous phase of the concrete's life, the last mile. This is where the carefully engineered material meets the chaos of the real world. Traffic, weather, and of course, human error.
A non-negotiable deadline governs this entire phase. Industry standards say that concrete has to be discharged from the truck within 90 minutes of being batched at the plant. This is not a guideline, it's a hard rule. Every single delivery is a race against this 90-minute clock.
The single biggest risk in these 90 minutes is human intervention. On site, workers under pressure might add unauthorized water to the mix just to make it flow a little easier. But this simple act completely destroys the precise water-to-cement ratio, undoing all the engineering from the plant and severely weakening the final structure.
Technology provides the solution through accountability. IoT sensors on the truck's water system can detect the exact moment an unauthorized valve is opened. An alert is instantly sent to the plant manager and recorded in the batch's permanent log. There is no longer an opportunity to compromise the material without being detected immediately.
Ultimately, all these different technologies, the sensors, GPS, AI, blockchain, they all converge to create one thing, a single, unbroken chain of data. And this transforms quality control. It moves it from a system that was based on trust and assumption to one that's based on verifiable, algorithmic proof.
And this chain is comprehensive. You've got sensor logs providing a second-by-second history of the mix. GPS data validates the entire delivery timeline, proving it met that 90-minute window. Blockchain guarantees where the raw materials came from. And the digital twin provides a simulation record that can be audited later. Every single variable is tracked.
This represents a fundamental shift in how we build. Our trust in a structure no longer relies on handwritten logs and the assumption that procedures were followed. It relies on a transparent, unchangeable digital record. This is more than just quality control. It changes liability, insurance, and the very nature of construction contracts because it replaces assumption with proof.
And this is the central idea. The material itself is ancient. It hasn't fundamentally changed in over a century. What has changed is our ability to see inside it, to predict its behavior, and to control its every property with digital precision.
And ultimately, that is the mission of this entire system. It's about using technology to take a material that is inherently variable and unpredictable and transforming it into a product that is consistently, verifiably, and absolutely reliable.
You know, this revolution in control isn't just limited to concrete. It leaves us with a final question to consider. What other seemingly simple, low-tech materials all around us, from wood to textiles to food, are being quietly transformed by invisible networks of data, turning chaos into predictable, reliable systems?